Hello, my name is Alexander Kuprin and I'm leading this project, MulticanisterOps. Let me introduce the team.
Hi everyone, I'm Stanislav Nivulin. I'm here to implement the SNS module, which allows users to approve builds through DAO voting. I'm excited to be here.
Hi, I'm Eugene, and I am a developer with more than 10 years of experience. In this project, I am focusing on demo applications.
This sprint we started to develop complex multi-chain cross-chain application that utilizes off-chain components. And during studies and architectural planning, we found out that it's not so easy to achieve our goals because of infrastructure and DevOps tools limitations. So we've started this project, MulticanisterOps, that aims to simplify the development of complex applications and focus on auto-scaling across subnets, do some nice CI/CD stuff to make development cycle faster and cleaner, and add some debugging and monitoring tools based on familiar toolset. Why after scaling an ICP is a problem? Actually, there was a huge trouble in November last year, and there was interesting forum post at Definity community from the representative of the second app in IC infrastructure. He shared the story of their growth and the path at scaling and their pains. Here's a long story short. Actually, they caused this trouble with Definity. Here's the story. They started from single canister, bottlenecked, then rewritten to multi-canisters. It was actually inefficient. They thought that ICP will automatically scale and will distribute this canister across subnets, but actually there is no subnet splitting in ICP, and it seems there will not be. And again, they rewritten their backend to balance across subnets by their own, and it totally crashed the internet computer. Definity team solved the issue, but it give a lot of attention on the problem. Uh, First of all, it's not so easy to develop efficient architecture to scale your app, and it takes a lot of time. Also, there will not be subnet splitting because some canisters need to communicate with each other fast, and they need to be placed in one subnet. If you split it, latency will grow, and it could be very bad for such applications. So it's a very time consuming to develop such a systems, but if you don't develop such system, you are limited to grow, and it's extremely painful for growing business to be blocked for months, and it could be fatal for business and marketing. There is a standard CI/CD cycle, development cycle in classical world. When developer builds something locally, then he pushes to development branch. It will be automatically deployed development stand. He tests it, then he pushes to release branch. Multiple developers push to the same release branch. It is automatically deployed to test stand. Distributed QA team will test it, write bugs, they will be fixed, and then release manager press button to tag the branch, and it will be automatically deployed to production around the world. But actually, it's not so easy with IC development tools. The fix is really great for local development. Sure, it could be Dockerized, but it is really hard to achieve same cycle with current tool set. And actually, we've tried, we have asked several DevOps engineers to help us with that, and nobody can't. Also, there are some tools for debugging in internet computer, but they are very specific tools, and all DevOps engineers not familiar with them because they use Grafana and other tools they are experienced in. But actually, we would like to see one unified dashboard in Grafana where you can see canisters and microservices and see how the request is going between them, and to monitor, debug, and make a system better. Here's a nice citation. I loved it so much because it fits our product, and because you can't build complex systems before you are limited with infrastructure and DevOps tools. And they need to be DAO. automation on updates, because decentralized application is not more decentralized when you have updates in centralized fashion. All these problems are solved in a centralized world. There are common tool sets, and we are solving these problems with the same tool set. It's very important to have a tool set that DevOps engineers and developers are familiar with, and it will help to propagate internet computer law across the developers. But we've added some components, PocketIC based component that hold it in a Kubernetes cluster, and in PocketIC there is a special WASM registry and a factory that orchestrates canisters and monitors them and shuts them and replicates across the subnets. Here's a plan. We push to the branch, GitHub action makes WASMs and Dockers, and then they are deployed to the Kubernetes cluster, and WASMs are deployed to the PocketIC and orchestrated there with our tool. Also, we utilize microservices architecture, so microservices communicate with each other by name, and inter-canister communication is abstracted away from the developer. Here's the scheme. Service 1 want to ask something. Service 2, it asks first DNS, get what canisters, what service can consist of what canisters, and try to make a call in a subnet, but it's not always possible because canister could be sharded to other subnet. And we utilize SNS for DAO. All deployments and updates should be voted in subnet or in mainnet. Our business model, we are open source, but we want to get some revenue on consulting and subscription for ready-made development infrastructure, but we focus on delivering value to developers to provide paid advanced features if they like our tool sets. And we need to focus on demo cases because everybody is learning by example. Everybody needs step-by-step guide how to solve certain cases. So here we're now in August, and next months we are going to show how to deploy complex applications easily with our infrastructure.